formula song, and they were not about that. Not at all. Sean, what do you think? There you go. Cool. Awesome. Okay, so in this problem, this is where we left off yesterday, right? If you need to, and I don't know that I saw anybody had it completely right. I didn't look really that closely. I was just looking for evidence that you tried it. I would encourage, if you're not confident in your answer, I would catch up and rewrite the exact same thing here and be prepared to cross out whatever work you did. Now, I'm seeing some very common mistakes, and they're easy to make, but the good news is that once we identify them, they're going to be easy to avoid as well. So let's start cooking. With this, yesterday we started with just this equation, and then I used the fact that I'm doing the same thing to both sides, right? I took the derivative. This is like we're done almost with the derivative, but I left us off with a step. Is everybody, let me rephrase, is anybody not okay with how we got this line right here? Why is there a cosine written here? The derivative of sine. And then why did I write this piece here? It's less for convenience, more about the chain rule, right? So here's the outside and inside. We take the derivative of the outside, we don't touch the inside, and then we take the derivative of the inside. And this is where I left you guys with. The derivative of 2x is just 2, right? So let's deal with this piece now, and I'll switch color as we do it. Do I need to change anything about this anymore? Nope, it's still cos xy. So we have the cosine of xy, and then now we need to think about in blue, just so we can identify it. And you know what? I'll use green so it's a different color than the others. How do we take this derivative? The derivative of x times y. It's a product rule. So help me out with this. I'm going to use brackets just because nested parentheses starts to look ugly. So I'll just change my grouping symbol to look nice. What's the first? X times the derivative of the second. And here we have a decision. Yesterday when we did this very first problem, we said the derivative of y was dy dx, right? Is there a more convenient way that we've ever written the derivative of y? Y prime. So first times the derivative of the second. I don't know what it is, but I know it's y prime. Like that's what we call it. Plus, now I do what? First times the derivative, I don't know why my letters just don't work there. First times the derivative of the second plus the second, which what's the second function? Y times the derivative of the first. And I normally wouldn't write it, but you guys help me out here. What is the derivative of x with respect to x? 1. Okay, still all equal to what on this side? Equals 2. Now, if you had this, then I'm comfortable with it. I didn't look that closely, and I'm sorry that I didn't. Anybody have exactly this? Nice job. Question? The 1? So check it out. Are you okay with xy prime? Plus the second, which is y, times, what's the derivative of 1x? Boom. Yep, and normally we don't even write it, but I just want to make sure it's clear. This is the derivative of the first. Okay, now it's equal to 2. And what are we actually trying to solve for? Do I have a y prime in here? Hey, let's solve for it. And now I need your help. If I want to solve for y prime, I don't need to do any more calculus. Like we're done with the calculus part of this problem. The rest of it's just algebra. So help me out. I want to solve for y prime. What do you suggest I do? Divide by cos xy. Sounds good to me. In the process, just so everybody's clear, I'm going to get rid of these brackets because once I divide by cosine, they don't mean anything anymore. So here we go. I get x y prime plus y equals 2 over the cosine of xy. We are trying to isolate y prime to solve for it, and the only way to undo this multiplication is to divide. Now, we're 2 steps away, or 1, depending on how you view it. I am going to show you guys how I view the algebra. It doesn't change anything, but I think it makes it nicer to view. Trying to solve for y prime, what would you do next? Subtract y. I'm cool with that. xy prime equals, and I'm going to keep this as 2 cosine of xy, but is there something else I could call this? So I would never do, like, I don't mind that idea, but I would never in a million years do that only because that looks like arc cosine. This is 2 secant xy, if you would rather do it, because 1 over cosine is secant. So 2 over cosine is 2 secant of whatever the argument was. I'm okay to not change it, but I just wanted to make sure that we had that, like, mentioned. So 2 divided by the cosine of xy minus y. Are we still all on the same page? Last step. If I want to solve for y prime and I don't want a common denominator, everything, how would I solve it for y prime? Okay, you are correct. Divide by x. Am I going to write it as this? And I don't always show my little steps like every time. We always speak about them. I can try to be better about writing them, and I should be better about writing them. But if I do this on each side, does that look nice? Kind of hate it, right? I don't know if you guys kind of hate it also, but I kind of really hate it. Instead of dividing by x, is there a way that we could view that with multiplication? Dividing by x, yeah. Dividing by x is the same as multiplying by what? Time out. I actually think I have a whole other box of them before I make you walk all the way down there. Psych. Oh, psych. Yeah, will you bring me 2 boxes, please? Sorry to make you sit there with needing to blow your nose. All right. Did we come to a conclusion here? Dividing by 2 is the same as multiplying by what number? So dividing by x is the same as multiplying by 1 over x, or 1x, if you will. I 100% of the time will do this because fractions divided by fractions sucks. What's the issue there? Oh. C'est la vie. All right. Do you guys know what c'est la vie is? So is life. Like, well, that's how life goes. C'est la vie. All right. So check it out. I'm going to multiply each side by 1 over x. And they gone. And check it out. All of a sudden, we now have an expression solved for what? Hey, that's a derivative with respect to x. And I'm just going to multiply this through here, just because I think it'll look a little bit nicer. We get 2 over the cosine of xy minus y over x. Once we get here and we're solved for y prime, do we have an expression where if I wanted to know the slope at some point, x comma y, do I have an x and a y for which I could plug in? Now, it looks weird because we've never had to do these, but we've never, and maybe we have a little bit, but I'm just going to, this isn't related to this problem specifically because the numbers are going to be super ugly, but check it out. Hypothetically, if we do a quick little show, if x comma y is on the graph of f, or do we start with f of x or y equals? We didn't start with anything. If x, y is on the graph, there we go, then what does the derivative really give me? The slope of the tangent line. So if xy is on the graph, then the slope at the point x comma y is, and this is just a notation thing just so we can see it, because I don't think we've ever had to do this. In this one, I have to plug in an x and a y, right? Like, it's a little bit uglier, but when we write this out, I can't just say y prime of 2 or whatever the case is. We have to say y prime of x and y. So we now have a function that would say, hey, here's x and a y value to plug in. Let's plug both of them in to get the slope. We're not actually going to find the slope here yet, but I just want to make sure that we front load that notation a little bit. Cool. We should do another one. Cool. All right. The good news is today it's just a bunch of examples. So let's see if we can't find one that's going to actually let us calculate out a derivative. As we're finding this, a couple questions. What were your mistakes? For sure, this is what I'm expecting anybody's mistake to be. You might have forgotten that you needed a product rule. You might have forgotten how the product rule worked. You might have tried to say the derivative of y was 1, which it would be if it was d dy, but it was d dx. Our notation starts to matter a ton. Okay. Sweet. I like this problem. Last one that we're going to do, and then I'm going to give you guys a bunch of time to work on stuff so that if there's issues when you're working independently, we can find them and deal with them today. Sweet. So, Mickey, I lied right to your face earlier, by the way, because this looks like we are going to get through 3.3 probably. Cool. All right. So here we go. Last example. This one, I'm going to name it new because we need something else. I want us to find the equation of the tangent line, and I'm just going to call it a tan line, to the graph of, and I'm going to be really wordy, but you guys can shorthand this as much as you want, the graph of y, nope, just kidding, x squared plus y squared equals 4, sorry, x squared plus y squared equals 4 at, or when, rather, x equals 1. Now, as we look at this, there's a couple of different ways, and there's always going to be some variation in the way that we write stuff down. So some slight differences in notation. I way prefer y prime of and then putting 2 points there. That's what I definitely prefer. But there is another way that we'll see in this problem. And here I am just stuck. Well, I don't know what to do. We're going to go like 30 seconds or 60 seconds-ish. We'll do 60 because I have a 60-second timer. I want you to chat with your neighbors. We're going to come up with an approach, and we're going to do this problem only calling on random people via the calculator. So chat with your neighbors, talk it out, random calls starting in 60 seconds. All right, speaking of purely coincidence, number 4 is the first one that I got. Who's number 4? All right, Abigail, the decision is yours. There's several places we could go. What's your first thought? With respect to what? Okay, so I'll take the derivative of each side with respect to x. And I won't really take it yet, but I'll write it that I'm going to. So here we go. d dx of, and we'll just keep this one blue in here, x squared plus y squared. And that's going to be equal to, I hate the color changing, d dx of what? 4. Okay, as we look at this, I will try to be better about this just consistently, but at least now it's on my mind. We just took the derivative of both sides, right? Deriv of both sides. And we're allowed to do that because algebra says whatever you do to one side, just do it to the other, and we're all right. My font is slanting as if I'm left-handed, and I don't know why. Weird. All right. Deal. I like that first step. Number 12, what you got? Is that you, Aisha? So I'll even let you pick. Which side are you going to give me the derivative of? Okay, what's the derivative of the right side? Gosh, that was tough. All right, the good news is that number 1, you get the other side. Okay, so I agree. It's 2x. And here is the big moment of truth, right? This is the part that everybody's trying to avoid. Number Delilah, what's the derivative of y squared? It's more than that. So we take the derivative of the outside. So the 2 goes out front. We don't touch the inside. It's still y. And then we multiply by the derivative of the inside, which, what's the derivative of y? Y prime. Nice catch. I could tell you weren't super confident, but you got it. Okay, at this point, can I solve this for y prime, the derivative? Okay, I'm going to do it in one step. I'm going to subtract a 2x. I'll then divide by 2y, and I'll have negative 2x over 2y. It's just negative x over y. You can confirm through simplification that when we solve, subtract 2x, and I lied, I'll just do it all here, just to double check the algebra. 2y, y prime equals negative 2x. Okay, rad, what do we divide by here to solve for y prime? Good, I'll divide both sides by 2y at this point. And I'm left with y prime equals negative x over y. Okay, wonderful implicit derivative here. The thing that everybody, not everybody, but the most common thing that people are going to miss is this 2y, y prime, right? That feels weird to do, but it's because we didn't take the time to really solve for y. And that's all right. Now, are we done? When x equals 1. Now, I actually made this problem a little harder than I have it in my notes, which is fine with me, but we have the derivative. I'm okay with this. this equation, and I'll write it in a different color, this gives me the slope. This gives slope of the tangent line, and I'm just going to say it gives slope m. If we know what? If we know x and y. What do we know right now? We know x equals 1 in my original equation. So careful. Notice, this is x and y. Is there any reference to y prime right here? No. So we have to make sure that we don't mix up, and this is why I'm so crazy about the notation. If you don't have d dx or dy dx or y prime, you're going to look at this whole mess and you're going to say, well, where the hell do I plug this in? If you are clear with your notation, there's no concern. We're asking about the slope to my original function at some particular x value. So check it out. We now need to find the corresponding y that goes with it, because all I gave you was an x. So here we go. Using the original, and I'm just going to write the original, x squared plus y squared equals what? 4. If x is 1, we have, and let's just do a little thinking and playing around with the numbers. So here we go. 1 squared, because I know what x is, plus y squared equals 4. Can we get the y value? Cool. I'm going to give you like 30 seconds. I'm just going to do some asterisks. What? That's not an asterisk. Hold on. Don't tell me. Tip of my tongue. Ellipses. There we go. What do you guys get for y when you get there? Love it. Positive or negative root 3. Why on earth would we get 2 y values for this? Because it's squared. A bigger question, do you guys recall what this graph is? It's a circle. If we imagine a circle, and I'm just going to sketch one here. I'm not going to go through the process of Desmos. This is a circle whose radius is 2, centered at the origin. R squared equals x minus 0 plus y minus 0 squared. So if we really roughly sketch this, a radius of 2, and it looks like this. Now when x is 1, we have a tangent line here at 1 comma root 3. And then down here it'd be 1 comma what? Negative root 3. There are 2 points where this would happen. And all of a sudden, we didn't have to deal with 2 different functions. We just deal with the one equation, and we get to make our choice. Which one are we going to commit to? We could do both, but I don't know that we really need to. Do we want this tangent line here or here? A or B? Which one's better? A or B? Sure. I was just trying to be a little optimist and optometrist this morning. We'll go with the positive one. So only because we're choosing, and I'll make that note, we will do the positive. We will do, and it's the point 1 comma root 3 by choice. Now, if you were asked to find the tangent line at both of them, you would have to find both of them. My original problem was just at 1 comma root 3, but I wanted to make sure we saw that there's multiple of them. So here we go. I have a y prime expression. I want us then to find the slope of the tangent line, or y prime, at what ordered pair? 1 comma root 3. Now, it looks ugly and gross, but if you know that f of x, you just replace the x, all I'm going to do is replace the x with a 1, and I'm going to replace the y with a what? A root 3. So here we go. It's negative 1 over root 3. That's our slope. Okay. With this, just so we have an alternative, and this one you will see, it is not my preferred, but give me another way to write y prime with maybe d stuff. So it's d over dx, but what's the function that we're differentiating? So we could write dy dx. Now, pretty common, not my preferred, but we might say this expression, y prime of 1 and root 3, might be written as this instead. These are 2 notations of the same thing. The value of y prime at this point, or the value of the derivative of y with respect to x at this point. Same thing, different notation. Which one do you prefer, purely out of curiosity? The red one? It feels more natural. This one we will see again, it shows up in another place. So let's check it. Do we have it? What's the slope at 1 comma root 3? It's this. It is this right now. What were we asked to find in this problem? Gosh, we need to find the equation of the tangent line. All we've done so far is found the slope of that line. Do we know the point it runs through? Well, by gosh, if we know the point and we know the slope, can we find the tangent line? Yeah. What would you like me to use? Which form of an equation? Yeah, let's use point slope since I have a point and a slope. So here we go. It is y minus, what's the y value? Root 3, that's the y that I run through in my point, equals, what's m? Negative 1 over root 3. Every class before now, has that been okay? Abigail, I disagree wholeheartedly. Have we ever left radicals downstairs? Never. Here's the deal. We can. We don't do it before because it shows up nicely on the unit circle as a nice way to see it. We don't have to do it here. Could you do it? What is 1 over root 3 with a rational denominator? Root 3 over 3, because we just multiply. Okay. Times x minus what? 1. Now, we now have this wonderful equation, and I will use Desmos here for just a quick second. Did we really do, like, conceptually, are we doing anything different? We're just using a derivative to find the slope and then plugging it in to get it. It just so happens that we didn't elect to solve for y equals plus or minus something gross. So we'll just confirm real quick, just so we can see it graphically on Desmos. If we type in that lovely circle at x squared plus y squared equals 4. Here it is. It's a circle with radius 2. And we had y minus square root of 3 equals negative 1 over the square root of 3 times x minus 1. Does that look like a tangent line to you? Now, we could do this at literally any point, right? And as long as we get a point that's on the original graph, that original circle, we can find the slope of the tangent line. Couple quick questions. Is there anywhere that I could not find the derivative on this? Follow up. I'm going to have you chat with your neighbors about this for a second. I'll tell you, there is at least one place, maybe more, but where on this graph can we not take the derivative and why? Okay, 60 seconds. I want an answer. Good or bad, I don't care, but I want mathy sounding answers. Where can't we take the derivative and why? Awesome job, by the way, on the answer there. Cool. So let's check it. We get some practice in class. So here we go. Today is, we didn't have homework yesterday? Why? Oh, that one problem, right, okay. So 1021, I'll add that in there in a second. 1022, this, I believe, was the conclusion of the chain rule. Let me double check if that's true. Not yet. We have one more type of example, but I want you guys to get practice with these first. So here we go. I'll fill in all the other stuff here in a minute. To start, we get homework 3.2.1, which you will find waiting for you on page 237. And we get a lot of time, but I promise this looks worse than it is. 5 through 13, 21 through 27, 53 and 55. Which that, like, you guys are all groaning, but that's 20 minutes for, I don't know how many problems are here, less than 15. Odds. Only do the odds. You can, like, realistically, I would encourage you to do the evens. I think it's a good idea if you need the extra practice. But for now, I just want the odds. Read all your directions very clearly and ask questions when you have them. This will be due at the start of class tomorrow. Those of you that might be traveling, if you don't get sick in aeroplanes, I would encourage just work the assignment on the plane. Why? None of my business. You don't have to tell me that. Good luck. You will bring yours back to me on Friday then. Cool. Okay, cool. Do it to it. I'm going to not end the video quite yet in case we can all agree that there's a problem that we have to work through together. Cool. So a little bonus at the end of the video here. On the assignment, number 11 was something that people wanted to work through, and we had some time in class. Now, I'm going to begin all these problems. we could try to solve it for y if you want, unless the directions say do it implicitly. So scratch that. We're going to not do that. You probably wouldn't elect to anyway. Now, when we want the derivative, how do I introduce that into the problem? I'm going to take not dy dx yet. It's just d dx, right? Now, this notation we haven't seen very regularly, but this is what's called the operator notation, which if you look back, we have it. And I don't really care what notation you use, but if I do this, it's telling me differentiate everything. D dx is what we used just now. This is just another way to write that. So let's check it out. This is an e to the u, right? Like an ugly expression. What's the derivative of e to the u? E to the u times one more thing. So here's e to the u, the same thing, I haven't touched it, times the derivative of something. So we need the derivative of this. What's the derivative with respect to x of x? 1 plus, what's the derivative of y? It's not 1. Y. If you guys all said y the first time and I just misheard, that's my bad. Are you sure the derivative of y is just y? Y prime. Equals, what's the derivative of this? Y prime. Now, this looks ugly, and maybe it's a little bit, but the same rules for algebra that we always use happens here. We need to get everything with y prime on one side, right? Now, unfortunately, I can't really move this one freely because I would divide by it, but then it just gets it in the denominator. If I don't want to have to divide by it, is there an easier option? Like if I had 2, 1 plus x equals x, how would you solve this? Everybody agree that you would just distribute right off the bat? This problem looks a heck of a lot worse, but it's the exact same situation. E to something is just a number, so let's try that. I'm going to distribute and just see where it takes me. Everybody agree that's e to the x plus y? Plus, and I'm going to change this. I'm going to write my y prime first. I'm going to write this as y prime times e to the x plus y equals y prime still. Before moving forward, have I lost anybody here? So if I have, check it out. I'm going to come back to this, and we're going to work this one at the same time. I do this, and I just get 2 times 1, which is just 2, plus 2 times x, right? That's exactly what happened here, but instead of 2, it's this. Now, realistically, if we did it the exact same, we'd write x2, which is still correct. It just looks wrong. Okay, I'm going to keep it 2x because I don't like the other one. Equals x. Can I get all the x's on one side? Probably. I'm going to subtract x, right? Now, this one's a little bit different. I'm going to subtract y prime. Now, if all that I want, and there's two options really, do you want me to subtract y prime or should I just subtract this piece over? Let's just subtract this over so we don't have to move two things. I'm going to subtract this from each side, which means on the left, I have e to the x plus y equals, and now on the right, it's y prime minus this whole terrible looking thing, y prime times e to the x plus y. And it looks bad, and it's kind of bad, but all I want is a single y prime. I can't really combine these. I don't know how they combine. If only there was an F word. Oh my, factor. What do you want me to factor out? Let's factor out a y prime. Okay? So we get e to the x plus y still, haven't touched it, equals y prime, and what would I have remaining? You're missing something. 1 minus, because this factors out of 1, e to the x plus y. And at this step, we're finally there. If I want to solve for y prime, how could I possibly do it? I'm going to divide it by whatever it's multiplying by. I'll divide both sides by this expression, and I'm going to switch it so y prime, bless you, is on the left. It looks like y prime is e to the x plus y divided by 1 minus e to the x plus y. And we're done. The good news is that if you got to this first little part here with the derivative, and you remembered to take the derivative of u, the rest of this just is an algebra problem. It looks gross, and it is kind of gross. It's like it's harder than this problem, but conceptually, there's no difference. Cool. What did you guys do? Or did you look at it and say no? Okay. Was that super duper hard after we did it? Now, it's always going to feel that way with math. I would encourage, don't trust your gut feelings of, nope, can't do it. Try it. You'll probably be okay. And if you're not, I'd rather figure out where you went wrong rather than just saying you didn't try. Cool. All right. Well, we got about 60 seconds left. So I will end the video here, and you guys can start packing up if you'd like. I will see you cool cats and kittens tomorrow with the exception of a few of you.